Business Development Manager at Milestone Environmental Contracting. And I will be moderating today's event, the fireside-style discussion on passive reactive barriers between Milestone co-founder and Director of Strategic Projects, Mark Seaman, and Western Regional Manager, David Meikle. Now, before we get into it, we just have a small video that we'd like to share with everyone.
After a decade of tackling the toughest environmental remediation projects, Milestone Environmental Contracting is just getting started. Let's celebrate with a look back on our first 10 years.
Milestone has taken the lead and been directly involved in some of the most complex remediation projects ever completed in Canada.
Together, we have a joint vision at improving the socio-economic conditions of our communities.
Mark Seaman and Barry Grover founded Milestone in 2011 with a purpose: to take on and excel in the tough and technical business of restoring damaged environmental sites and systems. Our founding values of ingenuity, collaboration, caring, entrepreneurial spirit, and accountability continue to be at the core of every project we take on. Early success brought us recognition within the industry, and an explosion of opportunities allowed Milestone to open up offices in Toronto and Langley, BC in 2014. The Langley office was built around Eric Pringle and a partnership with Matcon Civil. This led to signature projects like the Agassiz Landfill and Habitat Restoration and TFN Wetland Planting Project. In 2015, Milestone partnered with Andy and Wanda DeConti of DeConti Construction to tackle the Hydro-Quebec Corbeau project. From this, DeConti Milestone Inc., a First Nations-owned business, has given the Outaouais region a strong voice in remediation. Milestone continued to nurture joint ventures with First Nations partners in 2016 and expanded through projects in Alberta, BC, Ontario, Manitoba, and the Yukon. Our strong growth attracted the attention of Canadian Business and Maclean's magazines, who put Milestone on their 2019 list of Canada's 500 fastest growing companies. Again, in 2021, Report on Business put us on the list in the top 200 in Canada. Through 2020, Milestone completed 70 projects, including Esquimalt Harbour in BC and Randall Reef in Ontario, our largest remedial efforts to date. This astounding achievement showed that even a global pandemic wasn't deterring us from our mission. As Milestone celebrates its 10th anniversary, we're more dynamic and resilient than ever. Our reputation as the contractor of choice for environmental remediation and site decommissioning is growing. In the last 10 years, we've helped stakeholders across the country get clean, and we look forward to leading Canada into a sustainable future.
Well, we hope you enjoyed the Milestone 10-year anniversary video, and we are excited to have so many people participating as we launch into our bi-monthly lunch hour webinar series, where we aim to share a contractor's perspective, lessons learned, and experience on a variety of topics related to the environmental industry. Throughout the presentation, we'll be proposing questions and providing links to some of our future PRB projects that Milestone has completed. We ask that you take the time to share your feedback and propose questions on the Q&A, a function located on the right-hand side of your screen. Saying that, would also like to share a couple of housekeeping items. If you have any technical issues during the presentation, please comment in the chat, also located on the right-hand side of your screen, and our support team will be there to help you and address it as quickly as possible. Before jumping in, I do want to take a moment to acknowledge that the land in which we are speaking from today is the traditional and unceded territory of the Coast Salish peoples, including the Kwantlen First Nation, the Stolo Nation, and the Katzie First Nation. Given that we are gathered on a virtual platform and people are calling in from various locations, I would like to also acknowledge from coast to coast to coast, the ancestral and unceded territory of the Inuit, Métis, and First Nations people that we each call home. We do this to reaffirm our commitment and responsibility in improving relationships between nations and to improve our own understanding of local Indigenous peoples and their cultures. We thank them for allowing us to meet and learn together on their territory. Let's get to meet our speakers today. First up is Mark Seaman. Mark is one of the two founding partners of Milestone and currently directs the execution of our strategic projects. a civil engineer with over 25 years of experience in specialized environmental remediation and contracting. Mark has been involved in some of the most complex and impactful soil, water, and sediment remediation projects undertaken in Canada. His problem-solving ability on challenging, multidisciplinary projects is a definite asset. The projects that Mark has directed to completion have involved sediment, dredging, and capping, large-scale excavation and shoring, shallow and deep water cutoff, or reactive wall installations, and numerous approaches to on-site remediation, including chemical, biological, and thermal treatment. Mark, thanks for joining us today.
Thanks for having me, Mike. Appreciate
Excellent. Thank you. And last and certainly not least is David Meikle. David is our regional manager for Western Canada, and is responsible for aligning Milestone work practices and ensuring successful project execution across Canada. He has over 25 years of practical experience with environmental treatment processes and construction techniques, and has built a positive industry reputation for developing unique solutions to complex problems and delivering them in a safe and budget-conscious manner. He is particularly proud of his project success working in conjunction with Indigenous people as project stakeholders, partners, and fellow employees. In his role, David works directly with operations teams, leveraging his experience to drive project controls, develop work plans, maintain schedule compliance, and focus on health and safety initiatives. David, welcome to the panel today.
Thanks, Mike. Appreciate it.
Awesome. So formal introductions done. And look, I've got questions teed up for us to jump right into if you guys are ready to go.
Sure.
Yeah.
Excellent. All right. And I would just like to remind the audience, please, if you have any questions, post them and we'll do our best to get to them as we go here. So first up, guys, Dave, I'm going to go to you first. Personal experience on PRB projects. What do you got for us?
With PRBs, probably a dozen or more over the last 20 years, and then been involved with everything from supporting design, installation, and then also rejuvenation. And then you could double that number once you consider cutoff walls. They're often used in conjunction for funnel and gate type projects. So quite a bit.
Excellent. Excellent. Mark?
Yeah, thanks, Mike. Thanks, David. Similar. I think I was involved in my first PRB project 16 years ago, and since that time, I don't have the exact number, but it's in the dozens. No two projects have looked the same, so quite a variety of experience on installation methods, including one-pass trenching at depths of 10 to 12 meters, using trench boxes, drilled solutions such as caissons, and slurry trenching, biopolymer guar gum slurry trenching. So a lot of different installation method technologies and a lot of different media types used.
Okay, excellent. David, I accidentally skipped over you there from the sites perspective. Would you mind sharing with us some of the sites you've used PRBs on?
Sure. I think the one that triggers for me would be a large site in Vancouver, North Vancouver. It was part of a large wall that was installed there. Passive Reactive Barrier, over 100 meters long, depths varying about 13 meters deep, 1.5 to 2 meters wide. And it was a mix of ZVI or zero valent iron with composting material and pea gravel, and that was used to treat metals coming off the site. My involvement with that site was the original installation, and it's since been lengthened, and it's also been rejuvenated a couple of times, and I was involved with one of the rejuvenation events. That was one, like Mark was talking, where we used guar on the first time to put it in, and then in the rejuvenation events, we actually used caissons, square caissons, which I believe was the first. And then another large project that I remember quite fondly was in Alberta, in Turner Valley. And this was at a gas plant, and it was a funnel and gate system. So we used a combination of a bentonite cutoff wall and then a large concrete chamber that we put in as the treatment media. The reason there is was pHs. So primarily the media was carbon, and they were worried about rejuvenation efforts if we did a live bury, so buried it in the ground. So they put a big chamber in there so we could scoop it out on a regular basis to rejuvenate.
Excellent. So lots of experience then, and in different sort of stages and rejuvenation and extensions. So excellent to hear, and thanks for sharing, guys. One thing that came up that you both touched upon was cutoff wall. So for the sake of the audience and for me here, Mark, could you share with us what the difference is between a PRB and a cutoff wall?
Yeah, I'll try.
Thank you.
So PRB, I'm not sure if we've mentioned it yet. An acronym for Passive Reactive Barrier, and basically, maybe the confusing part of that description is the word barrier. A PRB wall is not a barrier to groundwater flow. It's a barrier to contaminant migration. So the wall is installed in ground, and it's purposely installed to allow groundwater to flow through it. The wall is installed with a specialized and designed media, which can vary depending on the contaminants. And that media creates a reaction within that wall to remove the contaminants from the groundwater as it passes through. So again, it's intentionally designed to allow water to flow through while treating and therefore being a barrier to contaminant migration. When we talk about a cutoff wall, and Dave used permeable wall, it's the opposite. It's actually a barrier to groundwater flow. So it's designed to not allow groundwater to flow through. And there's different types of cutoff walls that can be installed: bentonite slurry, soil bentonite mixes, concrete, etc., sheet piling. And often the cutoff wall and the reactive wall are used in conjunction in what's called funnel and gate systems. So if you have a site and you define the lateral extent of your treatment zone, then you can actually install a funnel, which is parallel, or sorry, two wings of a cutoff wall that directs the groundwater flow to a central reactive chamber or trench. So those are called funnel and gates, and that's an example of where you would use both PRB and cutoff walls. And we've done a number of those for our. Okay. So I hope that is clear and hope that helps. I don't know if Dave has anything to add to that description.
Nope. No, it's good.
Excellent. All right, on then. All right, so we'll jump to the next question here then. And it surrounds, how does one evaluate remedial options and consider design requirements of a PRB? And Dave, I'll throw that to you for an answer on this one.
Sure. I mean, the most obvious is what's your contaminant type, because that will determine the treatment media that you're going to use, and really is the crux of the whole point of the job. The next really important factor would be groundwater flow. You need to understand the rates and direction. This will help you decide the wall. It'll help you decide the thickness, the concentration of the media. So while the contaminant type might tell you what kind of media you need, the flow of it will tell you how long your lifespan of the wall will be with your concentration and your thickness. I think the other thing that's really important would be for soils, to understand your soils that are present. And by that, I mean geotechnical stability, so you can determine feasibility of installation. Also, the soil type will let you know about your performance for the transmissivity of the water through and how fast it will hit the wall. Because if you have a really silty soil, it's not going to work very well because you're not going to get the water moving towards your wall, right? Depth of water table. This will obviously determine how deep the wall is going to go, which is a pretty key factor when you're trying to figure out costs. And then again, installation and feasibility of that. And then also potential challenges and risks. So one of the things I've run into a few times is that there's been great studies done on where the wall is going to go, what the contaminant in the media is. But then all of a sudden, something as simple as underground services or an adjacent structure might be forgotten. And that has to be taken into account when you're talking about how deep these walls can go sometimes. So I think those would be the keys for me anyways.
All right. No, very good. Mark, any further comments you might add, or on to the next one we'll go?
I just might also add, again, in my previous question, I talked about funnel and gate. Part of your design might be to incorporate a funnel and gate type of system. Sometimes PRB walls, and we can get to it a little bit later, require replacement. Dave alluded to that, require replacement. So you might want to build it into your future development so that it's accessible and easy to replace. So that would be the other sort of aspect of the physical design of the feature. So
yeah, like I mentioned, the Turner Valley job, that was exactly the case. It wasn't cost effective to try and ring the entire site. It was almost a kilometer along the wall. And again, given the nature of the contaminants and the flow of the water there, the media was just going to get burnt up really quickly. And so the decision was made to do the funneling gate so that you could have a much easier way of replacing media rather than having to rejuvenate the whole wall at a pretty big cost.
Oh, very good. Insightful things to consider. And so it sort of jumps into a bit of our next question here, which, what type of team do you need to consider for a PRB project? You raise a lot of different elements that need to be considered. So what team needs to help support that when a PRB project comes up? Mark, I'll throw that one to you.
Sure, thanks. Yeah. As you pointed out in the previous question, or as we learned in the previous question, there's a number of design factors that are involved, and therefore it leads to a very much a multidiscipline type team. You have your environmental practitioners who will assist with characterizing the site and helping with the remediation means and methods, so the type of media that might be selected. And that's often verified in the lab prior to work with some bench testing. You certainly need to have hydrogeological input. As we've mentioned, you really need to understand the site characteristics, the groundwater flow regime, where it's flowing, how fast it's flowing. You want to make sure that whatever feature and whatever wall you build doesn't inadvertently direct the groundwater flow in a direction you don't want it to go. So there's definitely the hydrogeological aspect to it. And then installation methods. We're often dealing with deep installations. We can be dealing with challenging soil conditions. So there certainly is a geotechnical design aspect to it, to making sure that if it's a trench solution, that the trench is shored properly. If it's a slurry type installation, to make sure that the slurry program is designed and verified by a geotechnical engineer as well. So very much multiple disciplines that need to be brought together to be successful.
Excellent. And I'll throw this question to David, but to sort of add on to that, with respect to Milestone, are we able to address all aspects that we've sort of highlighted here? Dave, what are your thoughts around that?
Yeah, I mean, we won't do the environmental engineering or any of the geostructural, but certainly we're able to, act as a general contractor, GC for the site and lead that. So we've been involved in design builds where basically the base information is given to us on the water flows and ground conditions, and then it's up to us to come up with that design of what the wall should look like, whether it's just a straight PRB or maybe it's a cutoff wall, and then we can bring to bear the team that Mark's talking about, that multidiscipline team, to help get you to a design build. And that honestly is our favorite way to do these types of projects. They're technically complicated, and there are a lot of things you have to think about, and so to tie all those pieces together, you really want to lean on that experience that for people that have done it before.
Absolutely. Okay. Well, we'll keep moving forward here then. So real simple question for you guys to sink your teeth into. Why choose PRBs over other remedial options? And Dave, I'll go back to you to provide a response on this one.
Sure. I think, it's something to be considered if you have any site that you have offsite migration, and you might be looking at risk managing the site. There could be current land use, that you haven't finished using the site, but you want to deal with this issue. Any site that maybe remediation isn't feasible. There could be existing infrastructure, neighboring infrastructure that's not yours. The cost of the source remediation could be too high for the time. And I think this leads into maybe one thing that we left out with the PRBs. The difference between those and cutoff walls is they are temporary in nature, generally speaking. So the PRBs, you could have either a media that's capturing and holding on to the contaminant, or one that actually chemically alters it and cleans it and treats it, regardless of which one, you're using up your media. So that we talked about rejuvenation. Why would you choose a PRB? Well, you choose a PRB because you can't do a source site remediation for a variety of reasons. And so that's why you'd go with this method for sure. Buys you time.
Mark, anything you'd like to add to that, or we can move forward here?
I'll just, not necessarily adding, but reinforcing, where we see them being is when, full scale remediation is just not viable. It's a way to risk manage the site, protect off-site receptors from the impacts on the source site. And so a lot of owners are turning to these types of solutions. Just in some cases, it allows them to continue on with their land use or potentially alter their land use without embarking on a full-scale remediation project, assuming that the risks are environmental and human health risks are managed. So those are where we're seeing them. A lot of mine sites, large sites that can feature offsite impacts. Obviously, difficult to remediate an active mine site, but to control the offsite impacts, we're seeing different companies turn to these types of installations.
Excellent. The next question, and you've pretty much already answered it. It was really, what are the settings that it can be used in? I mean, you've alluded to some of the limitations that come with it, but to further your point, is there anything you'd like to share, maybe about the ground conditions or anything like that?
It's applicable in a wide variety of settings, and we've installed them in a wide variety of settings. It really just comes down to choosing the right installation method that fits into the site. There's often obstructions, buildings, property lines, utilities that could be impeding the installation. So we just have to make sure that the installation method factors in all of those. But we've installed them on busy commercial sites. We've installed them for municipalities that span their active roadways. I mentioned mine sites. There's a wide variety of settings that it can be installed in. It's just a matter of designing the right installation method.
Okay, excellent. You guys mentioned quite a few different projects in which you've utilized PRBs. My question for both of you, and Dave, I'll flip over to you for a first response, but what are some of the contaminants that you've treated with a PRB anyways?
Dissolved metals, petroleum hydrocarbons, chlorinated VOCs would be some that we've done. Those are the I think if we talk about the standard ones that we do, it would be the hydrocarbons and metals is the one for me anyways. So the ones that I've regularly treated.
Okay.
Yeah, similar. They've been historically used going back 15, 20 years for hydrocarbons, chlorinated petroleum and metals, as Dave mentioned. But we're also seeing emerging contaminants such as PFAS become more and more relevant, and we're seeing in-ground reactive solutions to those. We recently, earlier this year, installed a trial PRB at a site in Ontario to look at remediation or the impacts of the PRB media on PFAS. So very much in a trial phase, but we're definitely seeing PRBs used to deal with some of these emerging contaminants as well. So honestly, the short answer is they can be used if there's a media to treat a particular contaminant. It can be installed in a PRB. So there's all kinds of research that continues to happen. I mentioned lab testing and bench testing is a big part of this. Different medias are being tested for different contaminants. So it's constantly evolving.
Okay. Excellent. Thanks for sharing that. I'm going to take a moment real quick with the audience on just to revert back to the fact that there is a poll that's live right now. A few of the questions that we'd love to hear feedback on from everyone. I'm just going to share them right now. When hiring a contract for a project, what's the most important factor in your decision-making process? the different selections here. We're seeing so far past experience is the leading poll getter right now on that one. And then you go down to, at what stage of a project life cycle do you engage with the contractor? Seeing a few different answers, but the one that's jumping out right now is design and planning stage. So we'll touch upon a couple of the other ones as we go forward here. But, back to some of the questions that we have for today. In a lot of the conversation, you guys talk about longevity of like the PRB because they need to be recharged. So the question I propose to you, Dave, is, when would replacement be needed anyways? What are some of the factors?
Sure. Well, there's a lot of them. I mean, it depends on flow rate of the water going through the wall. It depends on the contaminant type and the type of contamination, or more like the concentration of it within what you're treating. I've had walls like that were kind of done in an emergency response, so a spill type situation that were good for less than a month. And then, when you talk about that site that I mentioned in North Van, it had a kind of a design life around 10 years before rejuvenation. So I think it's more typical that I've seen anyways that there are longer term type installation, because there's a pretty large cost associated with them. But it, again, like I said, I put in small ones that for very temporary situations to deal with kind of an immediate response, and it could be measured in months, but years, not, is the typical.
Excellent. Mark, any points that you'd like to add there?
Yeah, just to reiterate again, it's impossible to put a time period, actual time period on it, but they're generally measured in decades, not months or a couple of years. And there are lots of case studies. We don't have time, or we won't get into individual examples, but there's lots of information. There are case studies of walls that have been installed 20 plus years ago that are functional still. So that's the general answer to the question, but difficult to nail down.
It's something you pull out during the design phase for sure. Because I think that's a key factor during design is okay, rejuvenation, the frequency, what's the site going to look like in 10 years? Lots can happen in 10 years on a site, right?
Yeah, isn't that true? Okay, great. So time again here, we've been talking about different types of configurations for PRBs, and we're talking a lot about, what the benefits. But I would flip that question around and ask, are there any constraints to the technology being deployed? And, if you can highlight some of those aspects for our audience. Dave, I'll send it over to you.
Yeah, I mean, so we kind of already hit on that. There aren't too many. I mean, your length is kind of limited by your physical constraints of your site and your budget, to be honest. Mm-hmm. Depth, it's usually something that is constrained by installation techniques, and then also to what your ground conditions are like. It's pretty hard to put one of these through a bunch of bedrock, and you usually don't need to. But I've done conditions where you have a very fine, loose sand that wants to cave in. It can be pretty challenging to keep that open the deeper you go. I've had other jobs where you have layers of wood waste mixed in with that, and that can be pretty challenging to break through, because one technique that might work well for the sand is not going to work well for the wood waste. And so, you can run into depth installation techniques that way. The width is, it's funny. There's always a design width. I've never had an issue meeting design width, because generally speaking, the depth of these walls, the type of equipment you're using to hit the width, it always is bigger than that. And that's a factor to consider in the design too, is because people will be like, I want a wall 2 feet thick. Well, I don't have a machine that can dig 13 meters deep, 2 feet thick. It doesn't exist. So width is really, that's controlled by the installation technique rather than the design. And like I said, the bucket or the caisson, how big that is. So there's not too much that limits you other than the physical constraints of the site and your budget.
I'll just jump in and add. We've been kind of focusing on what I would call continuous barrier features. So whether they're trenched or overlapping caisson, there are cases where, in many cases where you create a linear feature barrier wall through the use of closely spaced but not necessarily connected borings, and you create these borings and inject under pressure the reactive media into the ground surface. So by doing that at a close enough spacing, understanding the soil conditions, you can actually create a continuous reactive feature. The advantage to using this type of installation method is you can go deeper in a smaller footprint. So if depth is needed, yet you're physically constrained from the size of equipment that would be needed to put in a continuous solution, you can put in a similar solution with smaller drill equipment. So there is that aspect to that flexibility of installation as well. We've been involved in a number of those too.
Yeah, that actually triggers a memory for me of a site, and that's the biggest thing is that Mark's right. They're not always just continuous PRBs. I was involved with a site in Coquitlam where because of existing infrastructure, it wasn't feasible for us to just do a continuous. So this was a wall that had cutoff features to it. It had these jetted in or drilled features as well, which were as good as we could get because we were right flush against an existing building, but it wasn't good enough for the whole site. So then we went to a traditional PRB beside that. And so it was like a combination of multiple different techniques to put it in. And there was even a structural component where we had to do cement with bentonite in it to create a cutoff, because they actually built a building over the wall after we were completed. And so they needed it as a structural component. It became actually, it is part of the design of the building. So there's not one size fits all for sure. They can be really complicated.
This is all great dialogue and insight that you've both provided. With respect to these, to PRBs, what about the QA/QC side of things? What are the considerations around that? Mark, I'll send that one over to you.
Yeah, well, it's important. Again, the media that you're installing is typically, or it can be, a mixture of multiple different products that need to be combined in a very specific recipe, if you will. And talked about bench testing. So you bench test different recipes, find out the right choice, and you want to make sure that that's actually what you're installing. So a big part of the QA/QC is around quality assessment on the media or the product that's going into the ground. And it's done. There's a number of ways to do that. I mean, it's done through grab sample processes on a periodic basis to assess. Sometimes a core of the installed wall will be used to affect to determine the effectiveness or the quality of the product that was installed. So that's a big part of it, and need to work closely with your designers on that. Other aspects when utilizing a slurry installation method, there's QA/QC on the slurry itself. So make sure that the slurry is meeting the requirements to maintain trench stability. So that's another aspect of the QA/QC. So it's definitely something that needs to be planned for. And
the other one too is the wall itself, the physical characteristics. I know there's a lot of effort put into making sure that it's the correct depth. In almost all cases, you're digging these things blind, meaning through some sort of support media like guar gum or bentonite or whatever, or some sort of slurry. And so it can be pretty challenging to make sure that the thing is installed correctly as per the design from a depth perspective. Like I said, width is usually not the issue because of the instruments you're using, but depth is the critical one. And I've seen where you can actually, because of the nature of most of the digging equipment like excavators, you can actually get a scalloping effect. And so you think you're hitting your mark, but if you're not pretty consistent and diligent with your QA/QC, you actually will miss those peaks and valleys, and you won't achieve the effect you're after.
Thank you for that, guys. I appreciate providing that insight. What about situations? We've talked about some constraints of different sites and limitations from a space and stuff like that. But what about situations where a PRB just isn't suitable? Mark, I'll throw that one to you.
Well, I mean, a PRB is not a solution to soil remediation. So if you have a site that features impacted soil that's creating an offsite migration of a groundwater plume, the PRB can definitely be designed to mitigate offsite migration of the contaminants, but it will not remediate the soil that's creating. So that's an important thing to note, that's it is not suitable for complete soil remediation at a site. It allows for control of that offsite migration that could extend the time period you have to remediate the site or change the remediation targets for the site, assuming that a safe land use can be determined. But it is not a substitute for soil remediation if that's what is required.
David, any points you'd like to add to that?
Just, I think we talked about it a bit before, but the ground condition, if you don't have a mobile water flow, then it's not going to be very effective. So you got to make sure that, the water is moving around, or the wall it'll be there, but it won't be doing anything for sure.
Okay. Take a bit of a pause here for a second and just want to highlight a couple of the other points that were brought up posted from a polls perspective. So we've talked about, what stage do you engage with contractors? The other question that's up here is, is your team considering a passive reactive barrier, PRB, as a remedial option for the upcoming project season? And then just some questions around, hey, what other topics do you want to hear from Milestone as we move forward with our webinars here, lunch hour webinars? So, make sure those votes keep coming. Love to hear the feedback from everyone, as it'll really guide, what the interest level is in the different topics that we have. So we'll get back to, I've only got a few more questions here. One of them, we've talked about your past experiences on these different projects, and there being a wide variety of different projects. So I would ask, what are some of the lessons learned on some of the past projects that you've been on? Dave, I'll throw to you first.
Sure. I mean, one of the lessons for sure is if you're going to use guar, stay away from it. It's a nasty, sticky substance that gets absolutely everywhere. And I've seen many of our guys and myself being coated head to toe, so it's not a fun substance. But aside from that, I think the biggest thing for me is just making sure that in the design, it's important to understand the ground conditions. When I think about challenges we've had on projects in putting these things in, it's always been surrounded to changes in what we're encountering and for the installation. You got to think that the technique to use it in, and I kind of alluded to that, where you might transition from, say, a gravel type substance to a wood type substance. Caissons, they'll slide through sand, but they'll bounce off wood. So you can run into some pretty costly headaches on installation if there's not a good understanding of what you're approaching. We've talked a lot about water flow. I think that's a critical factor for sure. One of the things to consider, and this is a lesson learned on a rejuvenation, is that these walls can condense over time or bind up. And so they'll actually turn into barriers themselves that has an unintended consequence of maybe pushing the water to a different location, or in other cases, making rejuvenation a lot harder than previously thought, right? So it's important to make sure you understand the life cycle of the media itself and any physical changes and characteristics it might go through, hopefully that can be done through bench scale testing. But, when you're talking about a 10-year lifespan, it can be hard to determine that. But that has a huge impact on the rejuvenation piece. So, I mean, those are some of the things that I've seen impact the job. I think making sure in your QA/QC, because Mark talked about that, the mix design, the media design, making sure that it can be readily tested in field. That design. I've also run into challenges on installation when there's lengthy delays based around the QA/QC involved with that mix design. And so that's something that needs to be processed out, because, I think sometimes bench scale testing is fantastic, but to replicate exactly that same thing in a field, with at scale can be a bit of a challenge. And so that has to be thought of. And I've seen that not been thought of and run into problems for sure.
Great points. Mark, any other points that you'd like to add to this as well?
There is one other. I will reiterate the importance of understanding the subsurface conditions. Things like large boulders can certainly impede certain installation methods, and those are challenging things to learn about in real time. But one other lesson to consider that we've learned is, once one of these walls are installed, the owner and their owner's rep want to see if it's working, and so there's a rush to get out there and sample some water that's, say, in a well that's down gradient of the wall that was to be installed. First of all, the PRB wall can't do anything to treat the water that's already past that point. Before installation. And so when you go to monitor existing wells that are down gradient and compare them to pre-installation concentrations, depending on the speed of the flow of the groundwater, you might not see the impacts in the first few months. It might take a year or more. And so you have to understand that. I mean, sometimes groundwater can flow at a few meters a year. And so it's going to take some time to see the positive impacts of the feature in your existing wall. So that's just something to consider when you're planning your post-installation evaluation is the speed of the groundwater flow. And you can do things like installing sampling points within the wall itself to verify that the reaction's occurring. So that was one lesson that came up for us previously.
No, that's a great point to bring up, that idea that yes, it's installed, but you may not necessarily see the results of that, depending on how quickly that groundwater flow is. So yeah, great point to raise there. With respect to planning future development around a PRB, we've talked and touched upon this a couple of times with some of the questions, but Dave, any other points you would raise here related to that? When you
talk about future development or future plans, it really around rejuvenation would be the key to think about. Like I already said, the site can change a lot in 10 years. So you have to think about, okay, well, because I've seen lots of plans. We're going to put this in, it's going to last for 10 years, and we're going to remediate the site before that. And then that doesn't happen. And suddenly you're in rejuvenation. So, again, you want to think about, well, what might be there that would create a challenge for the installation techniques that isn't there right now. So it could be a building, or it could be an adjacent site having something there. So really it's about maintenance of that wall. And then also too, your measurements, right? Because like Mark had pointed out, I've been on some sites where the reason you're putting the wall in is because a neighbor is about to develop their site. Well, what's that going to look like? You might not have control over that. So maybe you have to step your wall back onto your property a little bit in your original design to account for the fact that they're going to be altering their site. So it's all for me anyways. When you think about that is about future development. I mean, is the rejuvenation piece. The only other one, and I'd mentioned that too, is that you can also put sections of it that are cutoff walls, that are structural elements. Because again, if you're thinking, oh, well, maybe we'll put a building here or a roadway. Typically, you don't want to put that over this media, especially if it's something that's going to be pulled out in the future. So you have to break your wall with something that's more structural, and you can do that. We've done that. Just you substitute it with concrete for that section.
Great, thanks. Thanks for providing that insight, Mark. I've got one for you. It's fairly simple, but CapEx versus OpEx. Talk to me, the relationship between the two as it relates to PRBs.
I'll try to make it simple. When PRBs were starting to be installed 20 plus years ago, they were seen as an alternate to previous method of groundwater remediation, which was pump and treat. So instead of putting a reactive wall barrier in, practitioners were installing pumping systems, whether it's a collection trench or a series of wells that would actually take the water out of the ground, treat it at surface, and discharge it. And so passive reactive barriers came in as an alternate to that, and they still are. But so when you're doing a financial evaluation of the two technologies against each other, installation of a PRB wall is a high upfront cost. So you might consider that a capital expenditure with little to no operating cost. Whereas a groundwater pump and treatment system, I would say, has a moderate upfront cost, but a pretty high ongoing operating cost. And so if you're trying to take a look at the financial comparison or the financial picture between the two, you really need to factor in the true cost of a pump and treat system. So not just what it costs to install, but what's going to cost to operate that and potentially replace that in 5 to 10 years. So I think that's the kind of the question you're asking, Mike. I can say when you do those evaluations, the PRB walls stack up pretty well on a total cost basis.
Yeah.
We have an example here at a municipality in Eastern Ontario where the municipality went out for tender on a pump and treat system, and we actually submitted an alternate proposal to install a PRB, and we did that analysis for them, which I don't think that they thought of all the way through. And in the end, once they did that calculation, they did award the contract to us to install a PRB wall, and it was installed, and it's proven to be very successful. So yeah, those are the considerations between the two technologies.
Excellent. Thanks for that. And I'll just highlight to everyone, we've only just got 2 more questions left. We got about 12 minutes left in the webinar here, but last 2 questions. We'll start. Mark, I'm going to go to you on this, but obviously ESG is a big thing. Greenhouse gas emissions, infrastructures, road use, everything like that. So when we're thinking about a PRB, what are the ESG considerations that come to mind when evaluating a PRB and whether or not you're going to put one in versus other options?
I guess I'll stick to the environmental portion of that. I don't know of any social benefits to you, but sustainability wise, again, I think a PRB can form part of a different approach to a site remediation. One approach that is often taken is a complete removal of all the soil and groundwater from the site, trucking, hauling that material to an off-site disposal location, and then trucking in new material. But if you could alter that concept and develop a strategy to learn to live with the contamination that's on site safely, assuming that the human health and environmental risks are safe, you could install a PRB wall as part of that concept to deal with the offsite migration. And so a PRB wall can allow for that type of consideration to site remediation. That's very much recognized by regulators. And so I think when you think about sustainability factors, I think it's probably easy to see how that's a much more sustainable approach to dealing with the contaminated site than just hauling everything off to some other location. So does that help? I think that's one impact.
Yeah, no, absolutely. And I would flip over to Dave if he has any further comments to add to this.
Only to reinforce that. We've seen desire by municipalities in and around Vancouver, Metro Van itself, really trying to encourage the idea of in situ options, and this would be considered one of those. Just, less trucks on the road, less impact environment. You're dealing with your issue on your site. You're not just moving it somewhere else to be stored. And there are ways, like we said, with the funnel and gate or others too, that these can be a longer term solution as part of a full remedial effort. So definitely people are becoming aware, and more so every day of the impact that maybe traditional dig and dump remediation has, and kind of questioning some of the benefits. Excellent.
Awesome. Thank you for that, guys. One more question for you guys, but before we get to it, I'm just going to pop up a link here for those that are attending today. And this link will take you to some of the design build projects related to PRBs that Milestone has previously been on. So it's not the full scope, but it's a few of them. So if anyone, takes a look at that, has any questions, we highly encourage you to reach out and love to have a bit more of a conversation around what your potential needs look like and some of our experiences around that. So before we get there, last question for you guys. It's an easy one, and very simply, when is the best time to engage Milestone in the process? Dave, I'll go to you first.
Sure. I think for us, the earlier the better. I've already said it, or we've said it a couple times. Our preference is to help on the design build side. If we're there, we can kind of give the benefit of this experience that we've talked about and try and help to avoid some of those pitfalls. They're complicated projects, and to just think that one group or one team is going to figure their way through this is pretty daunting task. And so it's always challenging for us to arrive to a site as just an installer to see, oh man, I wish they would have thought of that. I wish they would have thought of this. So we're big on collaboration, and we like to make sure that we help people find the best solution to the treatment goals, really. And again, that goes to constructability, but also the maintenance and the future of that wall, for sure. So sooner the better.
Mark, any final thoughts around that final question there?
Just to reiterate again, I think the ability for us to bring value to the project increases the earlier that we're brought in. Generally speaking, I mean, not always, but generally speaking, yeah, the earlier, the more value we can bring in. As we've talked about, we've been doing this for many years. A lot of lessons learned. There's no sense repeating those lessons learned. So hopefully, we can help avoid those. And so yeah, we're willing to engage at any part of the process.
Excellent. Well, guys, that's a wrap on the questions that I had for you today. Fantastic discussion, a lot of value to be taken away with this. For those who have participated today, if you want to replay on it, we'll be making this on demand and on our Crowdcast page, live for people to go in there and check it out whenever they want to, pass along to their colleagues. And we encourage you to reach out to us with your next project, regardless of whether or not it's PRB, as we do a multitude of different service offerings on the environmental side and beyond. So please, engage us. And as the guy said, engage us early, and you'll really see the impact and the value that Milestone is able to bring to your project. So one last thing, in the coming days, we'd also love to get your feedback. So we'll be sending through a short survey, which we will be emailing, in hopes of getting more insight from the audience to really help us understand what it is that you guys want to see and what kind of value we can bring for you. I will bid everyone adieu and thank everyone for coming. And we hope that you enjoyed today's event, and stay tuned for our next webinar. Thanks a lot, David and Mark, for your support today.
Yeah, thanks, Mike, and thanks for everybody for coming.
Yeah, thanks everyone.
All right. Take care, everyone. Stay safe.